Hello everyone, we are starting a new chapter, chapter 4, discrete random variables and discrete probability distributions. Now, discrete is not our core subject, but we will start with discrete distributions first, and then next week we are going to move to continuous distributions. So, we know the random variables. A random variable means something where the outcome is not certain, so it's a random experiment. We classify the random variables into two types. In chapter 4, we will see the discrete random variables. In chapter 5, we will see the continuous random variables. So today, in this video, I will go over the discrete random variables. So let's start with the basics. The basic thing is in probability you toss a coin. And it can be tail or head. So let's say X is the number of heads when you toss a coin. Now, this could be 0, it could be 1, or it could be 2. Now, if it is tail, TT, then this will be 0 heads. It could be tail head or head tail. In that case, it will be 1 head. Or in some case, like it could be head and head, another option. In that case, we will have 2 heads. Now, the probability that x equals 0 is equal to 0.25. The probability that x equals 1 is equal to 0.5. The probability that x equals 2 is equal to 0.25. And here you see a probability graph actually. So the probability of 0 is equal to 0.5. Here we have 0, the probability is 0.5. Here we have 1, the probability is 0. Actually, the probability of 0 is 0.25. The probability of 1 is 0.5. And the probability of 2 is 0.25. Now, as we know that any probability has to be between 0 and 1. And if you add up all probability possible outcomes, the total should be 1. Now, we have something called the cumulative probability function. Cumulative means the probability up to that level. So, for example, we show it with big F x0. So, in that case, big F x0 means the probability that x is less than or equal to x0. It could be x0 and it could also be any number less than x0. That's called the cumulative probability function. So, continue with the same coin example. We know that the probability of 0, like 0 heads, is 0.25. The probability of 1 is 0.5. And the probability of 2 is 0.25. Now, fx here, that means the probability that x is less than or equal to that number. Let's call this x0. Now, the probability that x is less than or equal to 0, we only have 0. There's nothing less than or equal. There's nothing less than this number. So this is equal to 0.25. Now, for 1, that's a bit different, because the probability that x, for example here, let's make it again red. For this one, for example, this means the probability that x is less than or equal to 1. So that means x can be 0 or x can be 1. So if you add up these two probabilities, 0.25 plus 0.50, that will give us 0.75. And similar concept, if you add up the probability of x equals 0, 1, and 2, that will give you the total probability that fx, cumulative probability of x equals 2, and that's equal to 1. Actually, the last number here will always be equal to 1. So now let's continue with expected value. The expected value is based on a specific formula. We show it by Ex, and that's equal to mu for random variable. For each x, you multiply with the probability of x. So if x equals 0, the probability is 0.25, multiply, that will be 0. If x equals 1, the probability is 0.5, plus 1 times 0.5, plus 2 times 0.25, so the expected value equals 1. So that's how you expect. But it doesn't have to be exactly that number. You know, when you throw a coin twice, it could be 0 or 1 or 2 heads, but you expect to see 1. That's the idea. Now the variance formula is a bit more complicated. So the variance for discrete number random variable is sigma square, which is Ex minus mu square, and that's equal to summation x minus mu square px, which you can also calculate using this formula. This formula is actually easier to calculate. And once you find the variance, you can take the square root. Take the square root of variance. That will give you the standard deviation. Summation x minus mu square px, that's equal to variance. And if you take the square root, that will give you the standard deviation. Now, if you have more than one variable, and if you are trying to find, let's say, the variance of this combination of variables, let's say here we have another variable y, that's equal to c1x1 plus c2x2. Now, the expected value of y is easy. C1 times Ex1 plus C2 times Ex2. Now the variance is a bit complicated because in the variance we are taking squares. So variance of y is equal to C1 square Vx1 plus C2 square Vx2 plus 2 times C1 C2 covariance x1 x2. Now if these two variables are independent, linearly independent, that means the covariance is 0. In that case, the variance will be equal to this formula. But this only happens when the two events are linearly independent. So, normal conditions, this is the formula. But if they are linearly independent, the covariance will be 0. In that case, you can make it 0. So I'll skip the class activity. Now we know the basics of discrete distributions. We will look at specific types of distributions: binomial, Poisson, and hypergeometric. I'll skip the hypergeometric. So we will only look at the binomial and Poisson distributions. Now the binomial distribution is based on the probability of x successes in n trials. And the formula is here. The px is equal to, this one is a combination here. This is actually a combination formula. If you remember, that is cxn times p to the power x times 1 minus p to the power n minus x. And now we don't use that formula that much. What we need is, let's give an example. What's the probability of one success in 5 observations if the probability of success is 0.1? Now, once you see this question, first you need to find the parameters. Now we have 5 observations, so n equals 5. And we are looking for one success, so x equals 5. And the probability is 0.1. Now you have those numbers, just put them into this equation. So put x equals 1, n equals 5, and p equals 0.1, and that will give the probability of one success, which is equal to 0.32805. Now, what's important for the binomial is the mean. The mean is equal to n times p. So for example, let's give a simple example here. Let's say n equals 10. Let's say p equals 0.5. Now, in that case, the expected value will be n times p, 10 times 0.5, and that will be equal to 5. Now, you can also calculate the variance from this formula. Let's just put the numbers here. Same example, n equals 10 times p equals 0.5 times 1 minus 0.5, and the variance will be 0.25 times 10, which is 2.5. That will be the variance. And if you take the square root of variance, that will give us the standard deviation. So here's a class activity. We will skip that one. Now the Poisson is the second type of distribution. This is something very frequently used, especially in engineering examples. Like for example, you want to model the number of shoppers arriving at a mall per minute, number of clients processed in an hour, number of cars that pass by a highway, number of aircrafts that are produced in a month. So it's basically the number happening in a period. That's called the Poisson distribution. Now this is the formula for the Poisson distribution. Now, I know that formula looks complicated, but the key term here is the lambda. So if you know the lambda, it's actually very easy. You only need to know what's x. So lambda is the expected number of events per unit. Like for example, how many cars do you expect to enter the campus within an hour? That's lambda. So the Poisson distribution, the mean is equal to lambda, the variance is equal to lambda, standard deviation is equal to lambda. So in Poisson distribution, you only need to know lambda. And once you know lambda, you can calculate all the probabilities. And by definition, lambda is the same thing as the mean and the variance. So here's an example. Find the probability that x equals 2 if lambda equals 0.5. Now you can simply use the table. Lambda is 0.5, x equals 2. And in that case, it will be this number. But in many cases, you will not have the table. So you just need to put the numbers. So what we have is, we have the lambda equals 0.5. So put it into here. 0.5, 0.5 here. And we are looking for x equals 2. So put the 2 here. And also 2 is also here. And if you do the calculation, the outcome will be 0.0758. And this is how it looks like graphically. Now if you want to calculate all the probabilities from x equals 0 until 7, you can use the table, or you can simply put the numbers into the formula. and that will give you the graph of Poisson types of probabilities. Now, in Poisson distribution, the shape depends on lambda. If lambda is small, it looks like this type of shape. Now, this is right skewed. And as lambda gets higher, if the number of things happening per period becomes a high number, it looks like more like a curve. Actually, if it becomes too much of a curve, then we might even use normal distribution. And for this course, actually, we are going to use normal distribution very frequently. We will see it in the next chapter. So I'll skip the class activity. Now, one last thing about this course is this chapter. Not the course, of course. Independence. Now, we have seen in the last chapter that two events are independent if the probability of the joint probability equals px times py. So the same thing is here. Two events are independent if their joint probability is equal to the multiplication of their probabilities. So this type of thing, where the joint probability is equal to multiplication of probabilities, in that case, they are independent. And the same concept also applies to here. If you have more than two random variables, and if they're independent, the joint probability will be the same thing as their multiplication of their probabilities. Now, covariance and correlation, this becomes a bit complicated, but we mostly use computers to calculate the covariance. So the formula is simple. Covariance between x and y is equal to expected value of x minus mu x times y minus mu y. Well, we definitely need to use a table to calculate this number. Or simply, there's an easier way. The covariance between x and y is equal to expected value of x times y minus mu x times mu y. Now, once you find the covariance, you can find the correlation. The correlation is equal to correlation between x and y is equal to the covariance between x and y over sigma x times sigma y. And sigma x means standard deviation of x, sigma y means standard deviation of y. Now, correlation is always between -1 and +1. If it is 0, that means no linear relationship between two variables. If it is higher than 0, sorry, that means positive relationship. If it is less than 0, that means negative relationship. And the closer it gets to 1, stronger positive. The closer it gets to -1, stronger negative relationship. And we use correlation to look at how two variables are related to each other. Now, the covariance only shows the direction of the relationship between two variables. And if these two variables are independent, the covariance will be 0. So here's a simple example of how to calculate the covariance from a sample. Now, this is by hand calculation, but in many cases we simply use computer software like Excel to calculate the covariance for us. But this is how you calculate normally. If there's a table, you find x minus x mean. Of course, you need to find the mean first. Find the mean of x and find the mean of y. Find x minus x mean for x and y minus y mean for y, and multiply them. 2 times 2 equals 4, 1 times 1 equals 1, minus 1 minus 2, 2. Add them all and divide by the sample size minus 1, and that will give you the sample covariance. I can't see that number here, but I think it's something like 11.25. That gives us, that's how we calculate the covariance, using this formula here. Now the formula looks complicated. That's why you first find x minus x bar, and you find y minus y bar, like here and here, and then you multiply them, and you add them all together. You find the total and divide by n minus 1. Now for the population, you divide by n. For the sample, you divide by n minus 1, and that will give you the sample covariance.